In this video, I'm going to show you how to analyze the derivative using its graph to find relative maxes and mins and points of inflection. Which x value does h of x have a point of inflection? So the first thing we need to understand is that we're given h prime of x's graph. And a point of inflection is when the second derivative of h changes signs. Well, how do we know that the second derivative would change signs if we're given the first derivative's graph? Well, what we want to look for is where the graph changes from either increasing to decreasing or decreasing to increasing. And if we look on the graph here, we can see at x equal 4, we change from decreasing to increasing. So our reasoning here would be at x equal 4, because h prime of x changes from decreasing to increasing, you could also say, as long as you identify x equal 4, you can also say because h double prime changes signs. At which x value does h of x have a relative minimum? All right, so what we're looking for on the graph is we're looking for the critical numbers of h prime. We can see x equal 2 and x equal 6 are critical numbers, but now we're looking for a relative min, so we want to look for where h prime changes from negative to positive. And in this case here, it would be at x equals 6 because h prime changes from negative to positive at that value. Okay, in the last example, let's say we're given f prime of x is equal to x cubed times the quantity x minus 3 squared times x plus 1. How many relative extrema does f of x have? All right, so the first thing we're going to do is we're going to get our critical numbers, and that's where f prime of x would equal 0. And the critical numbers would be 0, 3, and negative 1. And then what we want to do is we want to set up a line graph to make a sign chart here. And what we're going to do is we're going to use test points to see what the value of the derivative is. So the first test point would be any value less than negative 1. So let's say I plugged in negative 2. So if I plugged in negative 2 into the derivative, that would give me a positive value. Okay. Same thing between negative 1 and 0. So let's say I plugged in negative a half. If I plug that into the derivative, that would give me a negative value. Between 0 and 3, if I use the test point 1, that would give me a positive value. And anything greater than 3, like the value 4, if I plug that in, that would also give me a positive value. So analyzing our line graph, we can see that there are two sign changes on the graph at negative 1 and 0. So at x equal 3 would not be a relative extrema. So in this case here, f of x has two relative extrema at x equal negative 1 and x equals 0 because f prime of x changes signs. Okay? So I gave you three examples of analyzing the derivatives graph. I hope that was helpful to you. So please like and subscribe. Thanks for watching.